Hello and welcome. In this video we're going to look at how to use a multimeter to measure voltage in a breadboard circuit, and we'll also look at Kirchoff's voltage law. I've made a simple series circuit here. I've used a 6-volt battery which is comprised of 4 1.5-volt cells connected in series, and made a series circuit that uses a 180 ohm resistor and 2 LEDs, a green one and a red one, and they're all connected in series. So by series, what I mean is that it's a single loop. The charge comes in here. This is red is the positive lead coming from the positive terminal of the battery. That is connected through these breadboard holes, which to this leg of the 180 ohm resistor. So the charge flows through here, through the resistor. That's connected to the positive leg of the green LED, so the charge will flow up through the LED. Which is connected to the positive leg of this red LED, so the charge flows up through there, down to here, and that's connected to the negative lead back to the negative terminal of the battery. So we have a series circuit. So now I'm going to show you how to measure voltage. Voltage drops and rises around our series circuit using a multimeter. So our multimeter is currently in the off position. We need to move the dial around to this region where we measure voltage. I've chosen the 20-volt setting because we have a 6-volt battery. So remember that voltage by definition is electrical potential difference. So when we measure a voltage change, around a circuit, what we're actually measuring is a difference in electrical potential between 2 points in the circuit. So if I measure the voltage across this resistor, then I'm measuring the difference in electrical potential between this side of the resistor and this side. Because the charges on the positive side of the resistor have more energy than the negative side, then this voltage is a drop. So we're going to put the positive probe of the multimeter on the positive side of the circuit, and then the negative probe on the negative side. And we can see there that we have a voltage drop across the resistor of 1.65 volts. So we'll write that down, that the voltage across the resistor, so voltage drop, equal to 1.65 volts. We can do the same thing for the LED, again touching the positive probe to the positive leg and the negative to the negative leg, and we have 2.10 volts across the green LED. So the voltage dropped across the LED is equal to 2.10 volts. I'll subscript that as green. Actually, I just would like to make a point here that when we have a number like 2.10, the multimeter is telling us it's not 2.09, it's not 2.11, it's 2.10. So that last zero is significant, and we should write it down, which we've done. So finally, let's measure the voltage drop across the red LED. So again, touching the positive probe to the positive leg, negative to the negative leg, and I get 2.03 volts across the red LED. 2.03 volts. Right, so we can work out the sum of all of the voltage drops around our circuit by adding those three together. So 5 and 3 is 8, 6 and 1 is 7, 5.78 volts dropped around the circuit. Now, this is where I will introduce Kirchoff's law. Kirchoff said that let me just get this all onto the screen. Kirchoff said that the sum of the voltage drops around a circuit loop is equal to the sum of the voltage rises. So in notation, we use this symbol, the Greek symbol sigma. So we say the sum of the sigma means the sum. So the sum of the voltage drops is equal to the sum of the voltage rises around a series loop, around a circuit loop. Alternatively, we could subtract the voltage drops from both sides of this equation, and we could get that the sum of the voltage rises minus the sum of the voltage drops is equal to 0. And yet another way of saying this is that the sum of the voltage changes around a circuit are 0. So if we consider drops as negatives and rises as positives, then the sum of the voltage changes around a series circuit loop is 0. Or around any circuit loop actually is 0. So let's just see if Kirchoff's law applies to our measurements. So far we have a voltage drop of 5.78 volts. Let's see what our voltage rise is across the battery. So to get the voltage rise across the battery, I touch the positive probe of the multimeter to the positive terminal and the negative probe to the negative terminal, and I have 5.80 volts. So the voltage across the battery is 5.80 volts, and that's a voltage rise. So we can see there that the sum of our voltage rises is very close to the sum of the voltage drops. It's 0.02 out, which is well under a 1% error. So that small error could just be due to measurement errors within the multimeter, or there could be a small amount of resistance in the battery clip. Either or both leads. So I think we've just shown that the sum of the voltage rises around our circuit is indeed the same as the sum of the voltage drops. So thanks for watching, and hopefully now you know how to use a multimeter to measure voltage in a breadboard circuit, and you know a little bit about Kirchoff's voltage law.